All right, well, here we are to review question 2017, number 2. So question 2, a certain grocery store opens. It has 50 pounds of bananas on the table. So let's just start there and highlight those units. We have 50 pounds of bananas. And that's right when it opens. So again, we'll take note that that's our initial condition. Okay, so now take note that we have a certain amount of bananas that are being removed from the table, where F of t is measured in pounds per hour. Okay, so this is a rate. It is measured in pounds per hour. And after the store has opened, some store employees add bananas. And this is also measured in pounds per hour. So if you haven't figured it out by now, it should be going off in your head that this is, I have an initial condition, and it's an in and out question. Some are coming in and some are going out. And we've seen this over and over and over. They love these in and out questions. And I think they're very obvious to catch. Add and subtract, initial condition. So part A, very straightforward. It just wants to know the amount of pounds that are removed. Okay, so I'm only focusing on the removed, and it says just pounds of bananas. So I'm going to go to my removed, which was this function here, and I just want pounds. So right now this is measured in pounds per hour. So what do I have to do to just get pounds? Hopefully you're saying just integrate from 0 to 2 of f of t dt. And of course this is calculator active. We're going to plug and chug that in our calculator, and I've got 20.051 pounds of bananas. Okay, part B, find f prime of 7. Well, mathematically, it's not going to get easier than that. You're going to hit n derive of whatever you have in typed 1. So I've got f prime of 7 equaling negative 8.120. Okay, so 1 point, simple calculation. The rest of the points are coming from this main question here, where it says, using correct units, explain the meaning of f prime of 7 in the context of the problem. So we need to explain in the context of the problem. So if you go back to that description of f, and let's reread this together. This is customers removing bananas from the table, so your sentence should talk about that. And this f of t was measured in pounds per hour. So let's think about what we just did. We took a derivative. What are our new units going to be? Pounds per hour per hour. So we know we have to get those correct units. If we took a derivative, our sentence should include the word rate. And we have to talk about the context of the problem, specifically at the number 7, since that's what we were asked to plug in. So I'm going to say, I'm actually going to pause this and write it out for you. And here's what I think your sentence needs to be close to. After the store has been open for 7 hours, since that was the number we plugged in, the rate, we have to have that word in there, at which the bananas are being removed, since that's what f of t was, from the display table is decreasing by 8.120 pounds per hour per hour. So why did I say decreasing? Well, my derivative was negative, which tells me that the function is decreasing. C, is the number of pounds on the display table increasing or decreasing at t equals 5? So again, let me just talk you through how I'm breaking this down. Increasing or decreasing, I get from taking a derivative. And they want the derivative of what? And again, focus on the units, pounds. I want the derivative of pounds of bananas. So the first thing I'm going to do is write an equation for pounds of bananas. I'm just going to call it b of t. So this whole function has to be about pounds of bananas. Don't forget you have that initial condition. You have the amount you started with plus the amount that came in and the amount that's being removed. Shoot, now I think f of t was the amount that's being removed. So g of x is the amount that's coming in, and f of x is the amount that's being removed. Why am I calling it x? Because my bounds are from 0 to t, and we need those to be two different functions. So right now, this should get me everything in terms of pounds of bananas, because both of these were in pounds per hour. So now everything's in pounds of bananas. So if I want to know if this function's increasing or decreasing, again, all I have to do is take its derivative. 50 becomes a 0, and this just becomes g of t minus f of t. And they want then to know that t value is specifically at 5, so I'm just finding b prime of 5, so I really need to compare g of 5 minus f of 5. So again, that should make sense. This is how fast they're coming in versus how fast they're going out. And if I want to know if it's increasing or decreasing, I'm looking at its rate, how fast something is happening. And I get negative 2.263. So I would say the number of bananas, make sure we answer the question, are decreasing. Now, I think D was a real nice question. I almost wish they would have asked this part before C, because obviously you're setting up the same equation. Find the number of pounds of bananas, so write yourself a function of bananas. Again, in pounds, that is the key word, those units. So you have 50 pounds plus the amount that comes in minus the amount that goes out. Whoops, call that an X. From 0 to T, and they just want you to find B of 8. So I'm just doing a nice plug and chug in my calculator. And I've got 23.347 pounds. Okay, so you have it, a nice in and out question again.